Now we can see what Lx, operator Lx into operator Ly is. So let's substitute for Lx here. What is Lx? Lx is equal to y into h cross by I dou by dou z minus z into h cross by I dou by dou I. I am substituting here y into h cross by I into dou by dou z minus z into h cross by I dou by dou y, that is Lx into z into h cross by I dou by dou x minus x into h cross by I dou by dou z. Okay, this is Lx. Lx, Ly, operator Lx into operator Lz. Okay. Here h cross by I is common everywhere. So let's take it out. Here h cross by I into y dou by dou z minus z dou by dou y into h cross by I into z dou by dou x minus x dou by dou z. H cross by I into h cross by I is h cross squared by I squared. I squared being minus 1, this becomes equal to minus h cross squared. And what is left? We have to remove the brackets. Y into dou by dou z of z dou by dou x. First term is z dou by dou x. Why did I write it like this? Because this is a product and hence we have to apply the product rule for differentiation. That's why. Minus z, let's multiply the first term plus y into dou by dou z into minus x dou by dou z, that is, therefore this is minus x dou by dou z minus z dou by dou y into z dou by dou x plus z dou by dou y of x dou by dou z. Now we have simplified and remove the brackets. Now let's see what each term is. Minus h cross square is common. Y dou by dou z of z into dou by dou x. Let's apply the product rule. First function into, that is, first function into means zy into dou by dou z of dou by dou x, that is dou squared by dou z dou x plus second function into, second function is dou by dou x of y into dou z by dou z, that is dou z by dou z is 1, therefore there is y into dou by dou x, y into dou by dou x. Now let's see the other next step, minus y into dou by dou z of x dou by dou z. That means here first function xy into derivative of the second is dou squared by dou z squared plus second function into, that is y dou z by dou z into derivative of dou x by dou y. Dou x by dou x by dou z. Dou x by dou z is 0 because these two are different variables. We cannot differentiate x with respect to z. Therefore, that term cancels out. Okay. Now, let's see the next term. Here also, first function into, that is z squared dou squared by dou y dou x. Second function into z into dou x by dou x into dou z by dou y. Dou z by dou y is 0. That function also cancels out. Now, the next term becomes plus first function into xz into dou squared by dou y dou z, and the next term is z dou z by z into dou by dou z of dou x by dou y, that is also 0. So now we have an expression for Lx into Ly which contains 1, 2, 3, 4, 5 terms. Okay. Now let's see what is Ly into Lz. Okay, substitute Ly into Lz. Substitute like before. Ly എന്ന് പറഞ്ഞാൽ എന്തായിരുന്നു? നമുക്ക് h ക്രോസ് ബൈ i പുറത്തെടുക്കാം. h ക്രോസ് ബൈ i into z dou x minus x dou by dou z into h cross by i lz എന്ന് സോറി ly lz എന്നല്ല, സോറി ഞാനത് എഴുതിയപ്പോൾ തെറ്റിപ്പോയിട്ടുണ്ട്. lx ly lx ആണ്, ly lx തിരിച്ചല്ലേ, lx ly മൈനസ് ly lx. അപ്പോൾ ഇവിടെ lz അല്ല നമുക്ക് വേണ്ടത്, lx ആണ് വേണ്ടത്. അപ്പോൾ lx വേണ്ടി വരുമ്പോൾ lx എന്ന് പറയുന്നത് y dou by dou z മൈനസ് z dou by dou y. ഇവിടെ എഴുതിയപ്പോൾ തെറ്റിപ്പോയോ? z ഇൻറ്റു അത് തന്നെയാണ് എഴുതിയിരിക്കുന്നത്. എഴുതിയപ്പോൾ തെറ്റിപ്പോയതാണ്, ബാക്കി സബ്സ്റ്റിറ്റ്യൂഷൻ ഒക്കെ കറക്റ്റ് ആണ്. ഓക്കെ, അപ്പോൾ വാട്ട് ഇസ് ly lx? ഓക്കെ, ദിസ് ഇസ് h cross i into h cross i is minus h cross squared. What is left is z dou by dou x of y dou by dou z plus z dou by dou x of minus, so therefore this term becomes minus z dou by dou y minus x dou by dou z of y dou by dou z minus of minus is plus x dou by dou z of z dou by dou y. Okay, അപ്പോൾ this is our expression. Now let's expand. This is equal to minus h cross square into, what is this term here? Since the second function is dou y by dou x, it cancels out. We can just write zy dou squared by dou x dou z minus z squared dou squared by dou x dou y